So, we left off here then. We finished talking about male anatomy. So now, pretty much the only last few slides for male repro is how sperm are formed. So this is pretty much the only conceptual part of the PowerPoint that we're getting to. So, spermatogenesis is the formation of sperm. Gametogenesis is the formation of gametes. And gametes are sperm in males and eggs in females. Okay, so right now we're talking about spermatogenesis. And for men, that begins in puberty. And men produce approximately 400 million sperm per day. 300,000 a minute. You don't have to memorize these numbers. Okay? And at any time, at any time of ejaculation, only 50 to 120 million are released. So guys can go a couple rounds and still be just fine, right? Again, reproductive system is designed to succeed, because how many sperm does it take to fertilize an egg? One, just one, right? Those odds are scary. They don't tell you that in grade school, right? During sex ed. They really should. 400 million per day, and it only takes one. So again, designed to succeed. Okay, granted, sperm have a long journey. They're very temperature sensitive. They have a long way to go. But again, the numbers are there for that, hopefully for success. So we're not going to talk too much about mitosis and meiosis, just the minimum to get through the concepts here. But what we need to review is chromosome number, okay? So most cells in the body we call diploid, and we call them diploid because they have 23 pairs of chromosomes, which makes a total of 46, okay? So most normal cells in the body have 46 chromosomes, 23 pairs, okay? And those cells get half of their chromosomes from mom and half of their chromosomes from dad, okay? Paternal and maternal. Now, in the body, we have cells that only have half that amount of chromosomes, 23. Okay, so there's only one pair, 23. N. Diploid is 2N, okay? The only cells in the body that are haploid are gametes, which again, in males are sperm and in females are eggs. And this is because when a sperm and an egg come together, that's when you want to restore the normal diploid number of 46. So you get 23 and 23 coming together, and then that restores the normal diploid number of chromosomes, okay? So, gamete formation of sperm, formation of eggs, involves meiosis, okay? And we need to talk a little bit about the difference between mitosis and meiosis, okay? So, again, this is just basic biology, just so that we get the numbers right, okay? So, when a cell divides by mitosis, okay, you get two daughter cells, right? Daughter cell 1 and daughter cell 2. Are those cells genetically identical? If you're going through mitosis, yes, right? So they're genetically identical, so both of those cells have 23 pairs of chromosomes, so they both have 46 chromosomes, okay? That's mitosis, all right? Meiosis. When a cell undergoes meiosis, are those daughter cells genetically identical? No, they're not, okay? The daughter cells for meiosis are only going to have 23 chromosomes, okay? So half the amount of chromosomes that mitosis has, okay? So for mitosis, you get two daughter cells, 46 chromosomes each, and they're genetically identical, okay? For meiosis, you get 4 daughter cells. So there's 2 rounds of meiosis that occur. You get 4 daughter cells that are 23 chromosomes each, not genetically identical, okay? Okay. So that's why gametes use meiosis, because gametes are 23. They're only haploid, right? So they go through meiosis, not mitosis. Okay? Stem cells in the body go through mitosis because they want to replicate themselves, right? And I'll kind of double down on that in a moment. Okay, so these next two slides, I'm not going to test you on the phases of meiosis, okay? If you want to review, update yourself on it, by all means go ahead, all right? But I'm not testing you on these two slides, all right? That's basic bio. Okay, so here is the pathway of the formation of sperm, okay? So at the very top, you have a daughter cell, okay? Actually, it's even before a daughter cell. It's a stem cell. So it's a stem cell that's hanging out in the walls of the seminiferous tubules, okay? So we're close to the outer membrane or the outer capsule of the seminiferous tubule layer, okay? So we got one stem cell that's undifferentiated. So in here is going to be the lumen of the seminiferous tubule, the inside of the seminiferous tubule where you guys found the sperm on the slide, okay? So that one stem cell then is going to be dinged by the body to say, okay, you're going to form sperm. So that one stem cell undergoes mitosis, okay? And it's going to form two genetically identical daughter cells, daughter A and daughter B, both diploid, both 2N, okay, 46 chromosomes. One of those cells, so daughter A, is going to stay behind and be the next stem cell in line to wait around, to be dinged, to then go through mitosis and continue the process again. Okay, so there's always one waiting, okay? So the other daughter then is going to go through one round of meiosis, okay? And once that daughter cell goes through meiosis, it's called a spermatocyte, okay? It's called a sperm cell. So it goes through a first round of meiosis, and it creates two haploid daughter cells, okay? And then those daughter cells undergo meiosis again and form 4 haploid daughter cells in total, okay? And each of those haploid daughter cells are called spermatids. So spermatocytes go from primary to secondary depending on what phase of meiosis they're going through. Primaries go through the first phase, secondary go through the second phase. So spermatids, okay, are the cells that have already gone through 2 rounds of meiosis. And now from here, these guys are going to start to mature. And they're going to mature into sperm. Okay? But these spermatids are only N. Okay? They're only haploid because they're going through meiosis, not mitosis. Okay? So this leads into the next slide, which is spermatogenesis, okay, which we discussed on the left-hand side here, just in summary, is the formation of sperm from a stem cell to mature sperm. That is spermatogenesis. Spermiogenesis is when you take a spermatid and you watch it mature into a sperm. That's spermiogenesis, different. Okay? So in the previous slide, we have spermatogenesis bracketed here. Okay? The whole process is spermatogenesis. And spermiogenesis, okay, is only the maturation of sperm from a spermatid. So it's only here, from here down, spermatid down into a mature spermatozoa. Okay, so a mature sperm has a long tail, okay? It has a midpiece where you're going to find all the mitochondria that are going to generate the fuel for these little guys, all right? And then you've got the head that has this hard cover on it called the acrosome. The acrosome protects the head, okay, because the head is where the DNA is. It's where the 23 chromosomes are. So the acrosome is a nice kind of hard helmet that is going to have to penetrate an egg in order for fertilization to be successful, okay? So that kind of leads into hard hat, you know, easier to hopefully penetrate an egg for successful fertilization, okay? Okay, so that's it for male. Questions about that? Okay, not as complicated. Females, we get a little bit more. Okay, so again, female repro, most of this is going to be anatomy. It's going to be a nice review of what you guys should already know. All right, so the gametes for females are ova or eggs, okay? Your ovaries are going to produce gametes and they're going to produce hormones, So your ovaries are exocrine and endocrine, okay? And every month, a female is preparing for pregnancy. Whether or not it occurs, doesn't matter. The body is gonna prepare for it every 30 days, okay? Starting with when a girl starts her period, okay? Okay, so the ovaries, again, we know they're held in place by the ovarian ligament, okay? The round ligament is not shown on this picture, but it's also a source of structural stability for the uterus and the ovaries. The broad ligament helps secure it against the pelvic cavity. And then you've got the suspensory ligament that brings in the artery, veins, nerves, lymphatic vessels into the ovaries themselves as an organ, okay? So ovaries, again, are under parasympathetic and sympathetic influence from the autonomic nervous system. So you do have nerves that penetrate the ovaries. So this picture looks pretty much like the model in lab, okay? Ovaries have the same covering that testes do. They have a tunica albuginea. It's the same thing. It's a fibrous capsule, okay? Ovaries have the same thing. Ovaries are solid organs, so they have an outer cortex and an inner medulla. The cortex is what houses the developing follicles, and that's what you guys identified on the model, right? So the medulla is going to house the artery, the vein, the lymphatics, and the nerves. Okay, that's all in the medulla. The hilum, or hilus, similar to the kidney, is just a region in the ovary where the vessels enter the organ. Okay, same thing. And the follicles we identified in lab, they're structures that start to grow. Okay, and we'll talk more about them in a bit. So we identified primordial, primary, secondary, and then Graafian, or vesicular follicles. Okay? Nothing really new there. Okay, so the ovarian cycle. A female every 30 days goes through 2 cycles, one in the ovaries and one in the uterus. And both cycles occur at the same time. Okay? So the first cycle we'll talk about is the ovarian cycle. The ovarian cycle has 3 phases to it. And typically a cycle lasts on average about 28 days. Depends on the girl. Could be 28 days, could be 30 days, could be 31, could be 27. It just depends. Okay, but on average about every 28 days. Okay, so the first 14 days, the first 2 weeks of the ovarian cycle is called the follicular phase. And this is where the follicles, primordial follicles, okay, are starting to grow and develop. And they're growing and developing under the influence of the hormone FSH, which is what? Follicle stimulating hormone. That's why it's called follicle stimulating hormone. So FSH from the anterior pituitary is going to target the ovaries and tell the follicles to grow, okay, in a female, during the follicular phase, the first 2 weeks, okay? Luteinizing hormone is also coming from the anterior pituitary. It's also going to target the ovaries, and it's going to tell the follicles to secrete hormones, specifically estrogens and some progesterones, okay? Estrogens are going to maintain female sex characteristics, but another hormone that we'll talk about more also, progesterone, okay, is going to target, down here it's in the luteal phase, it's going to target the uterus for pregnancy. So progesterone is going to be secreted from the ovaries, and it's going to go to the uterus and say, hey, ovulation is about to happen, get ready, we could possibly have a successful fertilization, okay? So, follicular phase ends after 2 weeks. That next day, that 15th day, okay, is ovulation, okay? You get a surge of luteinizing hormone, okay? And one Graafian follicle, okay, exudes its oocyte, okay? So during the follicular phase, about maybe 6 to 12 primordial follicles are chosen to start to grow and mature, okay? Because remember, a female is born with all of the primordial follicles she's ever going to have in her entire life, okay? So every month, when a girl starts, once she starts her period, about 6 to 12 primordial follicles are going to be dinged by her body to start to grow and develop. And of those, only one is going to make it to the Graafian stage. Okay? That lucky winner then is going to undergo ovulation and release that oocyte. That oocyte is going to be swept into the uterine tube by the fimbriae, by the fingers. Okay? And the uterine tube is going to bring it towards the ampulla, which is where fertilization occurs. Okay? You'll see that on a future slide here in a minute. Okay. So once ovulation occurs, then that Graafian follicle that released the oocyte then transitions into a corpus luteum. Okay, you guys identified that in lab. Corpus luteum continues to secrete hormones, estrogens, and also, more importantly, progesterones. The progesterones are going to go to the uterus and say, hey, ovulation just occurred, get ready, we could potentially have fertilization happening. Okay. If fertilization doesn't occur, okay, then that corpus luteum is going to scar down and become a corpus albicans. Okay, so every month, us females, we put a scar on our ovaries. Which ovary ovulates? There's only one ovary that ovulates every month. It's random. Random. Okay. Okay, so this picture pretty much shows you the model that you guys saw in lab, really. So we start off with the primordial follicles, okay? And then 6 to 12 of them, every 30 days, get dinged by the body. You are going to start to grow and mature under the influence of FSH. So they're going to turn into primaries, okay? Primaries are going to turn into secondaries, which is the beginnings of an antrum. You've got a nice oocyte inside. The zona pellucida is kind of like the acrosome on a sperm. It's like tissue around the oocyte that's going to protect it. And that's what the acrosome of the sperm has to penetrate in order for successful fertilization to occur, okay? Then one lucky winner is going to become a Graafian with the largest antrum. It's then day 15 going to undergo ovulation and release the oocyte swept into the uterine tube by the fimbriae, okay? And then the remainder is going to convert into a corpus luteum, secreting hormones, specifically progesterones that are going to go to the uterus and say, hey, get ready, okay, ovulation just happened, we could potentially have a pregnancy. And if that doesn't happen, it shrivels up into a scar called corpus albicans. Okay, and this happens every month. Okay, so in a mature or growing follicle, there are two different kinds of cells. There are thecal cells on the outside. It's called thecal folliculi on that, but it's thecal cells, okay? And then deep to those are granulosa cells, okay? And both of those cells perform different jobs. So I have it here on a summary slide for you guys next here. So we're pretty much just looking here at the left, okay? So this is showing follicle stimulating and luteinizing hormone being released by the anterior pituitary, okay? It's targeting the ovaries. So luteinizing hormone is going to specifically target the thecal cells, okay? And the thecal cells are going to make a hormone called androgen. Androgen is not sex specific, so it's a non-sex specific hormone, okay? So the thecal cells are going to tell the follicles, secrete some androgens, okay? So the follicles start doing that. Under follicle stimulating hormone is going to tell those granulosa cells then to convert those non-sex specific hormones into estrogens and progesterones, so into female specific hormones, okay? So the estrogens are going to promote continuation of the growth of the follicles and maintaining secondary sex characteristics, and then the progesterones are going to go down to the uterus to tell it to get ready for potential pregnancy. And then here it just shows you ovulation and then transition into corpus luteum. So we're not worrying about any of the dotted lines or anything. So just a summary between the granulosa cells and the thecal cells, what their job is, and under which hormone are they influenced by. Okay. All right, so how do we make eggs in females? Oogenesis, okay? It takes many, many years to happen, and it includes stem cells. Same thing for males. Okay, we start off with the stem cell, but once that stem cell gets triggered by the body to grow into a potential female egg, okay, it's called an oogonia. And then if that oogonia undergoes the first stage of meiosis, kind of like a primary spermatocyte, it's called the primary oocyte. If it undergoes the second phase of meiosis, it's called the secondary oocyte, kind of like a secondary spermatocyte. Okay? And then if meiosis 2 is finished, so if meiosis 2 finishes, then that oocyte turns into a mature egg called an ovum. Okay? So, meiosis 2 only finishes, okay, if fertilization is successful. If fertilization is not successful, meiosis 2 starts, but it stops. It does not complete itself. It only completes itself if fertilization is successful. And if fertilization is successful, then you have a mature egg, okay, that is developed from that sperm having fertilized it, because it triggered the end of meiosis 2, forming a mature egg called an ovum. Okay, we'll talk about polar bodies in a minute. So polar bodies are going to be the remnants of meiosis. Okay. Okay. So we're focusing on the left side here. All right. So we start off again at the top with the stem cell. We're talking female here, so oogonia. Okay. It's going to go through mitosis, and then that one daughter cell, okay, is going to undergo meiosis 1. Okay. But then it stops. Okay, so it's going to be arrested in meiosis 1. Okay, and then meiosis 1 will, the primary oocyte is going to undergo a second round of meiosis. Okay, no, sorry. How do I want to say this? Okay, so this primary oocyte is going to go through meiosis 1. So it's going to go through one round of meiosis, but it's going to arrest itself. So it's going to stop. So it starts off as a primary because it's going to go through meiosis 1, but it stops. So in meiosis 1, it's going to create one other cell. Okay, again haploid, just like this one's haploid. Okay, we're undergoing meiosis. So this is one round of meiosis. Okay, it stops. And it won't undergo meiosis 2 and complete meiosis 2 unless a sperm comes along and successfully fertilizes that egg. So that primary oocyte, okay, becomes a secondary oocyte, but it stops mid meiosis 2. It doesn't finish meiosis 2. If a sperm fertilizes it, then it will finish meiosis 2, okay, and form 4. Now, after meiosis 2, assuming fertilization is successful, okay, you create one mature ovum, okay, and the other 3 that are created by going through 2 rounds of meiosis are what are called polar bodies. And those polar bodies are non-functional, and they get resorbed by the body. Okay, so for every one stem cell or oocyte in a female, you get one mature egg. So it's a 1-to-1 ratio. In males, for every one stem cell, how many sperm do you develop? 4. Okay. 4, because that stem cell is going to undergo 2 rounds of meiosis and generate 4 spermatocytes, okay, that are going to mature into 4 mature sperm. So for every 1 stem cell in a male, you get 4 sperm. For every 1 stem cell in a female, you only get 1 egg. Okay? So the numbers are dramatically different. Okay, so that's it in terms of formation of sperm and egg. Okay? Questions? Okay, so fallopian tubes, uterine tubes, we looked at these, okay? We know the infundibulum is connected to the fimbriae. It's kind of like the palm, and the fimbriae are the fingers, okay? Ambula, again, is the enlargement right after the infundibulum. This is the site of fertilization. This is where normal fertilizations should occur, okay? And the isthmus is pretty much the continuation of the arm as it continues to the uterus, okay? So if fertilization is successful in the ampulla, then that little zygote, okay, comes down and then implants itself into the uterine wall and starts to grow and eventually becomes a fetus, right? Because that zygote is going to undergo mitosis, and those cells are going to develop into a fetus. Okay. And because you've got a sperm and an egg that have fertilized, you've now reestablished the normal chromosome level, right? You got a 23 and a 23 coming together, so now that zygote is 46. So it can now undergo mitosis and start to grow, okay? Maintaining the normal chromosome number. Half from mom, half from dad. Okay. Okay, so the uterus itself is normally kind of anchored slightly anteriorly on a female. You guys have already identified the regions, the body, the fundus, okay? The cervix you guys looked at. You looked at the cervical canal. You know the external and internal os. You know the fornix here of the vagina. So again, all the anatomy you guys already know. As far as the layers of the uterine wall are concerned, you guys have identified those. Perimetrium we know is the most superficial. It's consistent with visceral peritoneum, okay, because this is within the pelvic cavity. The myometrium is in the middle. It's a smooth muscle that's going to contract during labor. When a female undergoes labor right before childbirth. And then the endometrium is the inner lining, okay? Simple columnar epithelium. And this is what a female sheds every 30 days when she undergoes menstruation, right? There are 2 layers of endometrium, okay? The stratum functionalis is the layer that's shed during menstruation, okay? Deep to that is called the stratum basalis, and that's going to form a new layer once that stratum functionalis is shed every 30 days, okay? So stratum basalis is responsible for creating another fresh functionalis, getting ready for another 30 days where possible pregnancy can occur, okay? So when a female menstruates, she not only bleeds, but she also gets rid of tissue. Okay, she gets rid of that inner endometrial lining. It's not just blood. Okay, nothing new here. Again, the broad ligament, you guys know, secures the uterus against the pelvic cavity. Round ligament, it's not shown on here. Again, it's like an arm that continues around, actually attaches to the labia majora externally for structural stability. And suspensory ligaments is on the opposite side of the ovarian ligament that brings in the vessels to the ovaries as an organ. Right. 2 pouches are formed by the uterus and its relationship with the bladder, okay? So we have one anteriorly and we have one posteriorly. So the vesicouterine pouch, vesicouterine, is between the bladder and the uterus, okay? And then you have the rectouterine pouch between the rectum and the uterus. Okay, just 2 pouches that are anatomically formed by the uterus and its relationship with the bladder and the rectum. Okay, so now, at the same time that the ovarian cycle is going on in the ovaries, we have the uterine cycle going on in the uterus, okay? So the uterus is also under the influence of follicle-stimulating hormone and luteinizing hormone, okay? Based on what the ovary is shedding. If the ovary is giving you progesterone, then it's gonna tell the uterus to prepare for implantation, okay? If it's under estrogen, the estrogen is promoting follicular growth. Okay, so the uterine cycle has 3 phases, just like the ovarian cycle does, okay? First week of the uterine cycle is the menstrual phase, 1 through 5, on average about 5 days. This is where a female is shedding her stratum functionalis, okay? The second week is the proliferative phase, where the stratum basalis is forming a new functionalis, okay? So in the first 2 weeks, what's happening in the ovarian cycle? What phase what phase are we in the ovarian cycle? So the first 2 weeks is the follicular phase. So follicles are growing and developing under the influence of FSH and LH. So while those follicles are growing, the uterus is shedding lining and putting in a new one, getting ready for the next cycle, okay? So then ovulation occurs day 15, okay, in the ovaries, and then this is when the secretory phase occurs in the uterine cycle, where the uterus is then going to be hit by progesterone, and progesterone is going to tell it, hey, start to thicken your lining because we could potentially have a successful fertilization coming along the pike, okay? So the endometrium starts to thicken. All I want you to, this is just a visual of what we're talking about. So if you're a visual and you like graphs and stuff like that, this is just showing you a little bit of what's going on. So at about day 15, you get this huge spike in follicle stimulating and specifically luteinizing hormone. And that signifies what phase of the ovarian cycle? Day 15 is what?
Ovulation.
Ovulation. Ovulation is triggered by a surge in LH. Okay. So around day 15, in the uterus, you're going to get a ton of progesterone, because progesterone is going to go straight to the uterus from the ovaries and say, hey, get ready. We could potentially have a possible pregnancy. Okay? That's all we're really looking at here. It's just the visual. Okay. Okay. All right, so this is just nice because it just kind of breaks it down into 2 options. Okay? So there's either fertilization or no fertilization. Okay? If no fertilization occurs, okay, corpus luteum degenerates and becomes corpus what? Albicans. Okay? Progesterone levels go down. The ovary stops secreting progesterone. It stops telling the uterus to prepare. There's nothing to prepare for. It didn't succeed this month. We'll do it again next month. And then all of a sudden the endometrium sloughs off its stratum functionalis. Okay, we weren't successful this month, maybe next month. Okay? If the egg is fertilized, then corpus luteum is going to start secreting its hormones, progesterone specifically, that's going to target the uterus and say, hey, get ready. So progesterone is going to stay high. Also, if you pee on a stick, right, that human chorionic gonadotropin, okay, if you pee on a stick, you're going to have a positive, because that suggests a potential successful fertilization. And then the endometrium, instead of sloughing off, it's going to start preparing. Okay? The walls are going to start to thicken. So aside from peeing on a stick, if a female thinks she's pregnant, what stops? Your period stops. Your period stops because your uterus is getting ready. And it's housing a zygote. Okay? Okay. All right, so this is just a nice summary. Yay or nay? Right? Most of the time it's nay, thankfully. But again, it only takes 1 sperm, right? So, okay. All right, the vagina. So we got coats, 3 coats. Smooth muscle, it's actually designed to help bring in sperm, okay? Mucosa, because again, it's open to the outside environment, it's gonna have a mucosal membrane. You're gonna have stratified squamous, could have some activity in there, right? So you need protection, okay? And we've got rugae in the vagina, just like the stomach. What is rugae for? Why do you need rugae? Stretch, right? You need it for stretch. Okay, so we have a vaginal orifice. We know the fornix is a smiley face, kind of at the end of the vagina as it opens up into the external os of the cervical canal. Okay. Best for last. Okay, so we've got a couple things here that we haven't really identified in lab, but 3 of them here we have. So we know the labia majora and labia minora, we've identified those, okay. But the mons pubis is basically, we're not modest anymore in here, we're good, okay. Mons pubis, okay, is just the mound of fat and hair, pubic hair that a female has on the top. The labia majora is the female homologue to the scrotum in a male, okay. So it actually helps protect the orifices as well. The scrotum helps protect and house the testes, and the labia majora kind of helps screen those openings from the external environment. The vestibule is basically what houses the vaginal opening and the urethral opening. So it's kind of this bracket right here. So you got the urethral opening, you got the vaginal opening. Both of these openings together form an area called the vestibule, okay? And the labia minora, it kind of encompasses and encircles that vestibule. So it's a little bit smaller. Majora's on the outside, okay? We got the clitoris, okay? The clitoris is the female homologue to a male penis. It's erectile tissue, just like the corpus cavernosum and spongiosum in a male. Okay, we have a glans and a body on the clitoris, just like a male has a penis. And our erectile body is a corpus cavernosum, just like a corpus cavernosum in a male. Okay, males have more because, again, the penis is considered a conduit to exit sperm from a male reproductive system and enter a female reproductive system. So in order for that to happen, you have to have erectile bodies for the penis to be erect. And that, my friends, is Bio 220.